Good morning. This is 8-6, and we're going to be talking about how to solve um, quadratic equations like x squared plus bx plus c equals 0 without any leading coefficients. So let's go ahead and begin. Okay. The nice thing about this, I just do want to remind you, is that if you're listening to this in class and you don't understand something, you can rewind it and listen to it again, or you can raise your hand and ask me, and I can help you one-on-one. Okay. The other thing I want to point out to you is that if you need to pause it at any time, or you want to try it and see it on your own, and then you can, go forward, those are nice features. So let's go ahead and let's look at our learning objective. We will solve quadratic equations having real solutions by factoring equations of ax squared plus bx plus c equals 0. What isn't a quadratic equation? A quadratic equation is an equation in the form of ax squared. That exponent of 2 is what makes it a quadratic. If I didn't have that and a was equal to 0, then it would be, starts with an L, linear. If you guess linear, very good. Okay. So keep in mind, a cannot be equal to 0. Okay. You must have x with an exponent of 2. Okay. When you graph this, it's going to look like this. It's going to be a parabola, and that's spelled P-A-R-A. Okay. I know it looks kind of like parabola, but it's parabola. Okay, is the way we pronounce it. And it could look like a happy face, or it could look like a sad face, okay? One of the two. And these are called parabolas. Let's go ahead and get into our very first example. I'm going to go through all the examples today, and we will practice together. So the first one, example number 1. Remember when we were doing factor tables, we always want to add two numbers up, and we want to multiply two numbers down, right? So if we're thinking that this is in the form ax squared plus bx plus c, okay, what you're going to do is you're going to put a times c down here. And you're going to put b on top, okay? And if you think of a cute way to remember it, let me know. I'm thinking kind of like the AC is in the basement. I don't know. So if I'm saying, what is my value for a? I look at what's in front of x squared. Can anybody tell me what is in front of x squared? Good. If you said a was equal to 1, good job, because you have a ninja 1 right there, right? Okay. What is my value for b? 7. Very good. Now, if it was minus 7, you would make sure to include that with the 7 and make it negative 7. Okay. And my value for c? 12. Very nice. Okay. So when I put this in here, we're going to put the 7 on top. And we're going to put 1 times 12 in the bottom. Okay, so that's 1 times 12. Okay, so for today, all of our values for a are going to be 1. Okay, and then when we get into our next lesson, I'll show you what it looks like when we have something other than 1 for a. So now I need to know, what are two numbers that multiply to be 12 and add up to be 7? If I have a positive product, then I look up here at the top one and I see that this is positive. So I know all my signs have to be positive, right? In your calculator, if you have some difficulty with adding, subtracting, multiplying, I would recommend that you do this, that you're going to go, I'll put a little calculator tip here, calculator tip. Okay, you definitely just want to go to your calculator. You want to add a graphing page. You're going to see f1 of x equals, and you want to set it to this bottom number here, the 12. Okay? And then you divide it by x. And if this was negative 12, don't even worry about the negative, just do this. So I have the same sign, so I want to sum it up, right? Same sign, sum. So here we go, calculator tip, add a graphing page, put in your equation, and then you can actually look at a table by Control T. Okay? So for this first one, you probably could already do it in your head. What two numbers multiply to be 12 and add up to be 7? And the answer is 3 and 4. Okay? With example number 2, I'll go ahead and show you on the calculator since that one's a little tougher. But I've got 3 times 4 gives me 12, and 4 plus 3 is 7. Okay? So ladies and gentlemen, when we factor this, we take these two numbers, and we put them in here. Okay? So just keep in mind this one ended up going right here, and this one ends up going right there. And that's your answer. That's the whole thing, right? In your Cornell notes, I want to go ahead and prove that to you. Okay. Okay, so here we are back in our Cornell notes. I'm going to go ahead and write down a couple of things here that we can try to remember. First of all, same, sign, oops, extra E, my bad. Okay, same, sign, sum. Sum is just a fancy way of saying plus, okay? So when I'm adding and subtracting, this is when we're adding and subtracting, the rule is same sign, sum, okay? When I have different signs, we want the difference. So different signs, difference. Difference is just a fancy way of saying what? Subtract. Very good. Okay, so just kind of keep that in mind. I'm going to go ahead. We'll do the little box for you. Okay, so I didn't want to waste your time with watching me draw a box. But remember, this was example 1, where we came up with our answer being x plus 3 times x plus 4, right? So I'm going to go ahead and set that up. I've got x plus 3, and I have x plus 4. So x times x, what do I care about when I'm multiplying? When I multiply, I care about exponents. So are we going to change our exponents? Absolutely. Okay. What do I care about when I'm adding and subtracting? Very good. We care about our like terms, right? So just a little note to yourself, hey, when I'm multiplying, this is when I care about my exponents, right? So a little side note. All right, so here it's going to be 1 plus 1. So we end up with x squared, right? Then in this one right here, 4 times x, 4x. And this, 3x. And here, 12. So I'm going to add my like terms. Do I change my exponents when I'm adding? No, because all I care about is like terms. And I get my final answer of x squared plus 7x plus 12. So see, that was what they gave us originally, right? So it's kind of like they're giving us the answer and they're saying, okay, great. What two things multiply to become this? These are what we call the factors. That is why the answer was this. Okay, you can always test it by plugging it into a box and seeing, does this work? Okay, does it work in reverse? Let's go back to example 2. Okay, example 2, we're going to factor this one, okay? So remember again that it was B and it was A times C, okay? So what number is going to go up here? Negative 12, okay? And what is my value for A? 1. And my value for C? 27. So 1 times 27 is 27. Now these numbers are a little bit larger, right? But we're going to still apply the basic rules. If I have a positive here, there's two ways that I can multiply to get a positive, right? It's either like positive times a positive is a positive, good. And the other way to get a positive is to do negative times a negative, which is a positive, right? This one has a negative sum, so we're definitely going to put two negatives, okay? Same sign, sum. So I'm looking for two numbers that multiply to be 27 and add up to be 12. I'm going to go ahead and try out my calculator technique, okay? I'm going to create a graph, new document, adding a graph, and we're going to put in 27 divided by x. Enter. It really doesn't matter if you can see the graph or not because we are more interested in the table. And I'm looking for two numbers. Here is a complete table of all the numbers that multiply to be 27. Anything within a decimal in it, I don't care about, okay? So I'm looking for two numbers that will add up to be negative 12. And basically will add up to be 12. We don't really care about the signs at this point. So 1 plus 27 is 28. 3 plus 9, 12. So there's our answer, right? Let's take it back to where we were, 3, 9. I'm going to plug those in. I got negative 3 and negative 9. Okay? So now I just answer the question with x minus 3 times x minus 9. And we're done. This is the answer. Questions? Okay, if you have any questions about anything, raise your hand, call me over, anything to that effect, okay? But that's your answer. Let's go ahead and take a break. I'm going to create the next video, so there'll be a part 2 to this. All right, welcome back. We're at part 2 right now. Let's go ahead and start with example number 3. Let's go ahead and identify what A, B, and C is. A has a value of 1. There's a ninja 1 right there in front. Okay. We have B, which has a value of 3. And C has a value of negative 18. Remember, when we're talking about something, a term, and we pull it out and talk about it by itself, it becomes negative 18. When it's inside the expression, it's minus 18, okay? I have A here. Oops, no, not A. What is it? It's B, right? Because AC is in the basement. Yes, I can make this look better. We've got A, B here on top, and AC on the bottom, okay? So that means that 3 is going to go on top, and we've got 1 times negative 18 on the bottom. That's negative 18, okay? So I need two numbers that are going to multiply to be negative 18, and they're going to add up to be 3. Because I have a negative on the bottom, that means that automatically I know what my signs are, right? In order to multiply to be a negative, I have to have different signs, right? Whether it's positive times a negative or a negative times a positive, right? I added a 1 in there, but, not really, doesn't matter. And either way, I end up with a negative, right? Either way, I end up with a negative. So it really doesn't matter. If I see a negative here, I'm going to put a positive and I'm going to put a negative. Since I have different signs, I want the difference, right? Different signs, difference. Let's go ahead. Let's go to our calculator. And unless you can do it in your head, if you can do it in your head, you're awesome. Go ahead and do it and fast forward. But those of you who need the calculator, let's go ahead and do that. So we're looking for 18. Let me pull up that calculator. There we are. Now, we don't have to create a new page every single time. So if you already have it up, all you have to do is go up. Well, maybe. Okay, go to the right, go up. Will let me go up that way? You could flutter over here and then just change it right in there. And then we're going to put in negative 18. And I recommend just dropping the sign. So just saying 18 divided by x. Okay. And then hit enter. And it will update the entire table for you. Okay. If you don't like that method, you could definitely click on the graph here, select tab, and go up, and you can change it in there as well. Okay. So once we're looking at this, let's go ahead and look at our table. I'm going to click over here, make sure that my focus is in the table. And I really like to look at the positive numbers, right? So I've got 1 times 18. Now, if I go back, remember that we wanted different signs, different. So we need two numbers that we will have a difference of 3 that I can subtract and get a difference of 3. So 18 minus 1 is 17, right? No good. 9 minus 2, 7. No good. 6 minus 3, 3, right? Excellent. That's the one I want, 3 and 6. So now the only thing I got to mess around with is figuring out which one is going to go where. So remember the rule that we always keep the sign of the larger number, right? Keep the sign of the larger number. And since we kept a positive, our 3 is positive, that means that our larger number 6 is also going to be positive, and we're going to put the 3 here. And sure enough, positive 6 minus 3 is positive 3. Okay? And when we multiply positive 6 times negative 3, we get negative 18. So now that I've got my two answers, I'm really excited because I have my entire answer, and it's x plus 6 times x minus 3. Congratulations, you just factored this quadratic. Pretty easy, right? Yay. So let me see if I can do this, do a little shape. Okay. If you're good at adding and subtracting, which this makes it so much easier if you are, you don't have to use the calculator. You can just use your brain. Fabulous. Do that, okay? But for those of us that need a little practice, until we get to that point, we do have that calculator.